Hello, welcome back. Happy Monday. I hope you had a good weekend. So a lot of you guys have been working really hard, turning in your work, getting caught up. So I really appreciate that. Some of you guys still have some ways to go. So I'm going to make today short. This is the last lesson we have for surface area unit. So expect a practice test tomorrow. Then we'll move on to our last unit, which is volume, which we'll get that done in 4 days. So there'll only be 4 more assignments after today. So we're almost done. We got 10 days to get all 4 of those assignments in. So the last 3 days we'll be doing extensions. These are things that we usually do in the last like 3 weeks of school, where we get to go outside and do all the fun stuff. So I'll be condensing it down to just give you my favorites. The last one we'll do is Columbus versus De Triana, which I think you guys will really enjoy. It's my favorite one. It's got a really cool story behind it. It's like story time with Mr. Murphy plus a bunch of math, real world math, and it's my favorite one that I do, and I think you guys are going to enjoy that. Also, one more thing is if you have any photos or videos that you took during the year, whether I knew it or not, because that's always fun, of me probably doing really embarrassing, silly things, or saying embarrassing things that could potentially be used as blackmail against me, all the good stuff. If you have any of those photos or videos, if you'll send them to me, email them to me, I'm going to make an end of the year video like I always do. I might not post it on YouTube because I don't know if I want the whole world to see all that just yet, but I will definitely upload it to the Google Classroom so you guys can see it. You're the ones who really need to see it anyway. But anyway, so if you'll send those to me, let's get right into this. So I made a separate video. So if you want to know where this formula came from and just a really cool, just kind of example, some ratios between the surface area of a sphere and a cylinder, I think you'll really enjoy it. Actually, let me tease it real quick. But, so basically, here's the surface area of a sphere. It's 4 pi times the radius squared. Now, if you want to know where that came from, watch the other video. You'll kind of hopefully get a better understanding of it. To actually show you where it came from, the only way I know how to do it is use it involving calculus, because that's totally how my mind starts to think about when I start thinking about how you would derive from a curved surface, the surface area. So anyway, I can't show you that, so I did the next best thing in that video. So go watch it. And just to tease it real quick, whoa, what do these ratios mean? What is this? Oh my, Mr. Murphy, that's incredible. How did you do that? Wow, that's amazing. What's going on here? Well, if you want to know and have me explain all these cool ratios and what they mean, watch the other video. It's like 8 minutes long. I know you want to. And if you don't, then what kind of silly jokes or Illuminati math secrets do I reveal that you'll never know? And now you have to watch the video, let's be honest. Okay, so anyway, we have the surface area for the sphere is 4 pi times the radius squared. So from that, can we derive what the formula for the surface area of a hemisphere would be? So remember, hemisphere is half of a sphere. And if you think about it, you can probably come up with the formula for the hemisphere by just thinking about it. So if you want to pause the video and spend maybe up to a minute or whatever, just thinking about and seeing if you can figure it out before I just give you the answer, go for it. That's totally cool, and that's how we learn math. I encourage you to do that. But if not, let me show you. So the first thing is, if the sphere, the surface area is 4 pi r, that's the area all the way around on the outside of the sphere. So if we cut it in half, what have we done? So if we cut it in half, we take this hemisphere, the bottom half of it would have to have a surface area of 2 pi times the radius squared. But the problem with that is once we've cut it in half, we've introduced this new surface. This surface is going to be exactly the same as the area of the base, right, for the cylinder. If you go back to that video here, it actually has the exact same area here. So that would be the radius squared times pi, or pi r squared. So we have 2 pi r squared, which is the lateral area on the outside, right? And then we're going to add an additional pi r squared for this new surface we created once we cut it in half. It's got the same volume as it did before, but now it's got more surface area, which is kind of cool. And then so the hemispheres formula is going to be 2 pi r squared plus 1 more, which is going to give us 3 pi r squared. So those are our formulas. The sphere has a surface area of 4 pi r squared, and the hemisphere is 3 pi r squared. You don't need to memorize those. I'm going to give them to you on the practice test, so you'll be totally fine. So again, the sphere is 4 pi r squared, and then the hemisphere is going to be 3 pi r squared. So we got 3 pi r squared over here, 4 pi r squared over there. And the reason it's 3 instead of 2 is because we added an additional pi r squared once we cut it in half. So that was really quick, 5 minutes, and 2 of that was just me rambling on, giving you an update. So if you'll go ahead and get out your assignment, we'll go through a few of the problems together. So number 1, we want to find the surface area of the sphere given the radius is 5. So all we have to do is plug it into our formula, 4 pi r squared. So the radius they said was 5. So we need to put this in the calculator, but you can probably do it in your head. 5 squared is 25 times 4 more is going to be, or 4 times 25 is going to be 100 pi altogether. So our surface area is 100 pi. Number 4, this one's a little bit more challenging because it's a hemisphere, so we're using 3 pi r squared, but the real difficulty here is that the diameter is given instead of the radius. So be careful, when our formula is not the diameter squared, so radius squared. So half of 42 is going to be 21. So we're going to have 21 squared times 3. Now I don't know 21 squared, so I'm going to have to put that in the calculator. Oops, there it was. So basically we're going to do 21. You can either do 21 squared or just do 21 times 21, which is 441. And then we're going to multiply that times 3, which will give us 1,323 pi. Now notice we never multiplied by that pi, so it just stays in our answer at the end. If we wanted to know exactly millimeters squared, not pi millimeters squared, then we can just multiply that times pi. I guess we could do that times the previous answer. And that'll give us a decimal approximation. See, it wants to stay in terms of pi, which will be about 4,156 millimeters squared. Okay, so we're going to keep ours in terms of pi for this one. All right, 13. So the first 12 problems are pretty simple. You should breeze right through them. And then 13 is going to start getting more difficult. And this is the kind of stuff we're going to see on the practice test, especially because you guys are in honors. You should be able to do this stuff. So if I tell you there's an asteroid with a circumference of 83.92 meters, can you first find the radius? And then once you have the radius, can you find out what the surface area of that asteroid is? So you have to find the radius first and then the surface area. Well, the formula for the circumference is equal to, circumference is 2 pi times the radius. Well, they told us their circumference was 83.92. So the first thing I'm going to do is plug in that value, so 83.92, and then I need to solve for the radius. So how would I undo this 2 pi? This is multiplication, so we undo multiplication with an inverse operation, which is division. So I'm going to divide both sides by 2 pi. So once I divide this by 2 pi, make sure I have this right. Okay, yeah, I think we're good. So the 2 pi and the 2 pi are going to divide out to 1, and then all I have to do is put this part in the calculator. So I'm going to do 83.92 divided by 2 pi. Now I'm going to do this wrong just so you can see. And if you have a pi button on your calculator, use it. If you don't, then you can just use 3.14159 as an approximation. So whenever I do this, it's going to be wrong. And the reason this is wrong is because it divided the 2, but then it multiplied it by the pi. So if you have the fraction button, I would recommend using that, because then you can put the 2 and the pi in the denominator, and then it'll give you the correct answer, which should be 13.36 approximately when we round. All right, so the other thing you could do is you could divide them both separately. So 83.92, because I know you guys have different calculators or using your phone. So first you could divide it by 2, which is fine, and then you can divide it again by pi. And I'm going to use approximation this time. So 3.141592654, but we'll just do 159, which gives us exactly the same answer, except not exactly, because we got a little different precision because I only did it to that many decimal places. I didn't go any further, but that'll give you 2 decimal places where we're able to use it'll match your answer. So should be fine. So that'll give us a radius of 13.36. So radius is 13.36. Now that we have the radius, we should be able to find the surface area. This is just like the problems we did 1 through 12. We just had to find the radius first. So it's kind of like 2 problems in one. So plug in that radius into our formula. So that's not 21. No, it should be 13, which makes me feel like I might not have updated the other one. So 13.36 squared, and then we multiply that times 4. All right. So I'm going to take this value because it already has the precision in it. In fact, I want to go back up to this one because that's where I use the pi button. That'll make me feel better about myself. So I'm going to take that and I need to square it. So squared, and then multiply it times 4 pi. So 4, and let me use the pi button again so I have all the precision there. And so that gives me 2241. So 2241. And that's probably not going to match because maybe this one does. No, it doesn't. Okay, that's because I didn't use pi. So because your answers are left in terms of pi, we're actually going to divide the pi back out of it, which should give us that value. Yeah, that's where it is. So this one never got updated. So it should be 713.56. I hope I didn't mess this up. Yeah, and that should match your answer bank because the surface area, this is actually left in terms of pi, which is Alt 227. There we go. All right, so that is it. Our radius is going to be 13.36 and the surface area is 713.56 pi. Now, if you're getting something close to those decimals but not exact, that's probably because you're not using the pi button. Like I kind of showed how you could do it with an approximation. But on the test, you're going to be multiple choice, and so you'll just pick the one that's closest to it if you don't use the actual pi button. All right, 17. So on this one, they give us a surface area of the sphere is 16 pi centimeters squared. From that, we need to derive the radius and then find the circumference. So we're just kind of working backwards from what we just did before. So this time we're going to start out with our formula for the surface area. They tell us the surface area is 16 pi, so we can go ahead and plug that in. And then we have 4 times pi times the radius squared. Well, we don't know the radius squared. That's what we're going to solve for to find the radius, right? That's the first thing we need. So on this one, we have 4 pi. We want to get the radius squared by itself. So the first thing we're going to do is divide both sides by 4 pi. So 16 divided by 4 and pi divided by pi, you should be able to do that in your head. That reduces down to 4, right? And then over here on the other side, we just have the radius squared. So radius squared is equal to 4. So therefore, the radius is just going to be equal to the square root of that, which is 2. Now that I have the radius, can I find the circumference? Sure. It's just 2 pi times the radius, which would give us 4 pi. All right, number 20. So it's actually a pretty cool problem, and you'll have one very similar to it on the practice test, so make sure you understand how to do it. We've got a softball, which has a diameter of 3.8 inches, a baseball, which has a diameter of 2.92 inches. I actually looked this stuff up, which is even cooler because this is real data. And then we want to know for part C, what's the difference between the surface area of a softball and the surface area of a baseball, which is kind of cool. So just using our formula like from problems 1 through 12, we're just doing it twice and then subtracting the difference between the two. And we're going to leave our answers in pi as well. So 4 pi times the radius squared. Well, this one's going to have a nasty decimal, so I'm going to have to use my calculator to find out what that's going to be. So 1.9 squared, and then I'm going to multiply it times 4, which is going to give me 1444 pi. So that should be one of our answers. So 1.9 squared times 4 is going to be 1444 pi inches squared. So that's the surface area for a softball. So now for the baseball, we're going to do the same thing here. If you're not sure what half that is, you can always put it in your calculator. So 2.92 should be about 1.4, or sorry, that divided by 2. 1.46, yeah. So we get 1.46 squared, and then we multiply it by 4. So I'm going to take that value, I'm going to square it, and I'm going to multiply it by 4, which will give me 8.5264, which I rounded. The answer will be 8.53 on your answer bank. Now, if I want to find the difference, how much larger is the surface area of the softball than the baseball, I just need to subtract these two. So when I do this, I'm going to start out with my 14.44. Notice they're both in terms of pi, so I could actually leave the pi out if I want, and I do. So I'm going to do 14.44 minus the previous answer, so I'm going to arrow up. That way I have all that precision, and then that's going to give me 5.913. So when I round to 2 decimals, it's 5.91 pi. So 5.91 pi inches squared. So how much larger is the surface area of a softball than a baseball? Well, it looks like it is about almost, I don't know, about 40% larger. All right, 23. All right, so on this one, we're the first few problems here are actually fairly simple. Just kind of a review of what we did on the second day and the third day, and then the last problems are going to be a little bit trickier, but we'll do one of those as well. So on this one, we want to find the area of the sector or the arc length. So if they give you a shaded region, you're finding the sector area. And if they give you a part where one of the arcs, part of the circle, the arc of the circle is darker than the other parts, then that's the arc length one that you're going to find. All right, so we want to find the sector area. Our formula, you might actually have this kind of memorized by this point, but I put it on the assignment and it'll be on the test as well. But we just have two parts. We have the fraction, which is how many degrees out of 360, so what fraction of the whole circle. And then the next part is the whole, which is the area of the whole circle, which is pi r squared. So we can plug in our values. We're doing 45 degrees out of 360. And then the fraction of the whole is going to be, the area of the whole thing is going to be 100 pi because it's 10 squared, which would be 100 pi. So 45 out of 360 of 100 pi. And we can just put that in the calculator if we're not too sure. We can use our fraction button as well. So 45 over 360 multiplied by 100 pi. I'm going to leave the pi out so that it's left in terms of pi, and then convert it to a decimal, which is 12.5. So 12.5 pi will be my final answer. All right, so the last one, the last four problems here, these are definitely the hardest problems because you got to work backwards from the arc length or sector area formula to find the radius. And this is the most challenging ones that we have, but you can totally do it. First thing you definitely need to do is show some work and write the actual formula and fill in the values, then use your algebra to solve, okay? And I gave you plenty of room to do it as well. So if you just write the answer, it looks a little suspicious, if you know what I'm saying. All right, so the area of the sector, they're telling us with the arrow, this area shaded in is 10.8 feet squared. So first part, we're going to fill in the area of the sector is 10.8 feet squared. Then the number of degrees that we have, if this is 72, then the supplement of that, because this is a diameter, so it's a linear pair, is going to be 108 degrees. So we're doing 108 degrees out of 360 times the area of the whole thing. Well, we don't know the area of the whole thing. We only know the sector area. So that's going to be just left as pi r squared. So first thing we want to do is we want to get the radius by itself, but we got to get rid of this fraction. So how do we undo a fraction that's being multiplied? We multiply it by the reciprocal. So what's going to end up happening is we're going to multiply both sides by 360 and then divide them by 108 degrees. And that's going to end up getting rid of the fraction on one side, and we'll have it on the other side now. So what I need to put in my calculator is going to be 360 times 10.8. I'll do 10.8 times 360, and then I'm going to divide that value by 108. So if you notice, what we did is we went from the fraction of the whole to the whole of the fraction, which is kind of weird. So this proper fraction, which is, I don't know, about 1/3, we're saying this is about 1/3 of the whole thing. So it's 1/3 of the whole area. Well, if I want to find out the whole area, I just put the fraction backwards. It's kind of like working a scale factor problem, but I'm going from the big one back down to the small one, or vice versa. So the fraction backwards will take me the other direction, like a scale factor. So 360 divided by 108, which is about 3, will be approximately three times as big as the area sector is going to give me the area of the whole thing. So that's what's happening there. It's kind of cool. We're going from the sector to the area of the whole thing, which was a value of 36. So we got 36 pi over here. Or, yeah, I think it actually is, no, it's just a regular 36. The pi still stayed on this side. So 36 is equal to pi times the radius squared. Now, how do we get the radius squared by itself? First, we have to divide both sides by pi. So 36 divided by pi. And if you use the pi button, you'll get the exact value. But if you use a approximation, then it'll get you close enough to get the answer, which is totally fine. So 11.46 when we round to 11.46. Now keep in mind that's what the radius squared is, and it's approximation because it's a decimal approximation. So then to find the actual value of the radius, we just have to take the square root of that, which is the 1/2 power, which leaves us with 3.39. So 3.39. All right, so just under 20 minutes should be totally fine. Go through those problems, get it uploaded when you're done, and then after this, tomorrow, or depending on when you're looking at this, so Tuesday, which will be the 28th, I'll post the practice test. So as soon as you're done with all your assignments for chapter 11, go ahead and take that practice test. And then in a day or two, I'll post the solutions to that. Once I have enough data, enough of you guys take that, then I can post the solutions and show you what kind of problems you're missing and what mistakes you're making. So we'll do that just like we did last unit. I thought that worked out really, really slick. And then on Wednesday, we're going to move on and start doing our volume unit. That way we'll have those 3 extra days at the end to do some really cool extensions. So I will talk to you guys later.